Welcome viewers, in this video we will see the solved problem based on the sinusoidal response of RLC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. RLC circuit. R, L and C are connected in series. R value is 5 ohm, L is 1 Henry, C is 0.25 Farad. This is the transient current. We need to find the value expression for this transient current. The applied voltage is exponential form, 6 e power minus 2t. The switch is closed at t equal to 0. I will see the statement. In the circuit zone, the switch is closed at t equal to 0. Obtain I of t, transient current. Assume 0 current through the inductor L and 0 charge across capacitor before closing the switch. So before closing the switch, there is no charge and no current in the inductor and capacitor. That is the initial value is 0. Now we'll see the equation for this given RLC circuit. In time domain, the equation of the above circuit is based on the KVL, Kirchhoff's voltage law. We can write the equation. So based on KVL is nothing but the voltage, applied voltage equal to voltage drop across resistor, voltage drop across inductor and capacitor. Otherwise, voltage rise equal to voltage drop across these three elements. So based on that, 5 into I, voltage drop across resistor, 5 into I, plus voltage drop across the inductor, 1 L di by dt, the L value is 1, and 1 by C integral I dt, that is the voltage drop across capacitor. 1 divided by 0.25 integral minus infinite to 0 I dt plus 1 divided by 0.25 0 to t I dt, that is equal to 6 e power minus 2t. So this is the applied voltage, right? So 5I is di by dt plus, so this initial value of charge is 0 even in the problem itself. This is the initial value of charge. This is the charge voltage drop across at the time t equal to 0. So this term becomes 0. So 5I plus di by dt plus 1 divided by 0.25 integral 0 to t I dt equal to 6 e power minus 2t. Now we need to take the Laplace transform in order to convert from t domain into s domain. After simplification, we have to take inverse Laplace so that we'll get the current in t form, that is a transient current. Now we'll take the Laplace transform on both the sides. So 5 is constant, Laplace of I is I of s. Laplace of di by dt is s into I of s. 0.25 is constant. The Laplace of integral is I of s divided by s. Differentiation means s into I of s, integral I of s divided by s, equal to 6. 6 is constant. E power minus 2t is 1 divided by s plus 2. So this is based on the formula e power minus at equal to 1 divided by s plus a, right? So a value is 2 here. So 1 divided by s plus a, s plus 2, based on this formula. I will take this I of s common. So 5 plus s plus 4 by s. 1 divided by 0.25 can be written as 4. 4 by s equal to 6 divided by s plus 2. Now we'll take this LCM. So here s value not available, multiplied by s. Here also s not available, multiplied by s, it becomes s square plus 4 divided by s. Now we'll bring this term on that side, so that this term will go to the numerator, this term will go to the denominator, in order to obtain the expression for I of s. So it is written as s divided by s square plus 5s plus 4. These two terms available. So 6 divided by s plus 2. So this can be written as, this quadratic equation can be written as s plus 1 plus s plus 4. Right? We know that if we add these two, will give the coefficient of s. If we multiply these two, it will give the coefficient of constant. So that is based on that it is splitted. It is a very simple quadratic equation, so it is splitted. If it is not there, we have to use the formula minus b plus or minus square root of b square minus 4ac divided by 2a. But here it is easily splitted. So finally we got I of s equal to 6s divided by s plus 2, s plus 1, s plus 4. So we'll take this equation number 1. Now we'll use the partial fraction technique in order to split this term. After splitting only we can take the inverse Laplace. Now we'll see how to take the partial fraction technique. So by partial expression technique, the equation is written as k1 divided by s plus 1 plus k2 divided by s plus 2 plus k3 divided by s plus 4. So if you split like this, we can easily take the inverse Laplace. So this equation, this is the equation 1, that is written like this. So both are same. Now we'll take these three term common, LCM. We'll take these three term LCM, so that for the further simplification. Here s plus 1 is available, so multiplied by s plus 2 and s plus 4. Here s plus 2 is available, so multiplied by s plus 1, s plus 4. Here s plus 4 is available, multiplied by s plus 1, s plus 2. Now these three term available on both the sides, so it is got cancelled. So finally we got this expression 6s equal to, right. Now we can we need to find the value of k1, k2 and k3. That is the next procedure. How to find the value of k1, k2 and k3? We have to substitute the value s. We have to select the value of s such that it will cancel the two terms. Here three terms available. If we substitute s equal to minus 1, what happened? This minus 1 plus 1, 0. This term total is 0. Here also minus 1 plus 1, so total is 0. We can easily calculate k1. Similarly, if we substitute s equal to minus 2, this term and this term got cancelled. We can easily find k2. If we substitute s equal to minus 4, this k1 and k2 cancel. We can find k3. So select the s value such that it will cancel the terms. So s plus 2 is there. So we will substitute minus 2. Here minus 4. Here minus 1. We can select the value. So put s equal to minus 1. The minus 1 is substituted. See this plus 1 minus 1 becomes 0. Here plus 1 minus 1. That also becomes 0. Only this term is available. k1 into minus 1 plus 2 is 1. Minus 1 plus 4, 3. So it is 3. Minus 6 equal to 3k1. So k1 equal to minus 6 by 3 equal to minus 2. So now we got the value minus 2. Now substitute s equal to minus 2. So that we are able to find the next value. So s equal to minus 2 is substituted here. See here minus 2 plus 2 cancel. 0. It becomes 0. Here also minus 2 plus 2. This term becomes 0. Only k2 is available. k2 minus 1 plus minus 2 plus 1 means minus 1. Minus 1 plus 4 means 2. Right. So minus 12 equal to minus 2 k2. So k2 equal to minus 12 by minus 2. So 2 negative available 2 times. So it is cancel. Negative cancel. k2 equal to 6. Now we calculated the k2 value. Now we will substitute the s equal to minus 4. So this s value is selected from the equation itself. We have s plus 1, s plus 2, s plus 4. So first we substituted s equal to minus 1, then s equal to minus 2, now s equal to minus 4. Right, s equal to minus 4 substituted. See this here, plus 4 minus 4, 0. Here also minus 4 plus 4, 0. Only this term is available. k3 into minus 4 plus 1 means minus 3. Minus 4 plus 2 means minus 2. Right. So minus 24 equal to 6 k3. So k3 equal to minus 24 by 6, it is minus 4. Now we'll substitute the values. So this is the equation 1. By partial fraction technique we split it. Now we can substitute k1, k2, k3 value. k1 is minus 2, k2 is 6, k3 is minus 4. Now it is rearranged. Minus 2 into 1 divided by s plus 1 plus 6 into 1 divided by s plus 2 minus 4 into 1 divided by s plus 4. So it is written in a standard form. Right. We know that this e power minus at equal to 1 divided by s plus a. Right. So we will take the inverse Laplace on both the side. By using the formula we can write. So minus 2 is written. 1 divided by s plus 1 is e power minus t. Here a is 1. s plus 1. So a is 1. So e power minus t. Similarly, s plus 2. A is 2 here. So e power minus 2t. S plus 4. Here a is 4. E power minus 4t. Right. So based on this formula, it is written. So finally, we got the equation for transient current of the RLC circuit. Minus 2 e power minus t plus 6 e power minus 2t minus 4 e power minus 4t. Based on this formula written. So in this video we discussed the RLC circuit, sinusoidal excitation of the series RLC circuit. We obtained the transient current, expression for transient current. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.